So I have a very thin needle, a sewing needle, and I'm going to take this and place this right into the top of my bottle. I want to try and balance this clear plate on top of the needle. If I let go, do you think that this will balance? Write down your predictions. What do you think? Well, obviously it doesn't. Let's try it again. No such luck. What can we do to stabilize the plate? Make sure that the mass that's on or distributed on my plate would allow me to do an impossible task of balancing my plate. Here I have some pieces of raw potato. I didn't have to use potato, I could have used really anything, but this I thought would be easy to insert my forks that I'm going to apply my masses with onto my plate. Let's try it. Now we want to make sure that it's equally spaced. Okay. Now that seems to be leaning more towards this side, and I think that that is because one of the potatoes may be a little bit too big. I think that that's what's going on here. Is that one of the potatoes may be larger in size than what we want. Let's change this potato out. Let's see if it makes a difference. It works. What do the forks do to the center of gravity of the system? Where is the center of gravity located of the plate without the forks? What changed? Where is the center of gravity located now with the plate and the forks combined? What would happen if I blew on the potatoes? Do you think that the system could rotate? And where would it rotate around? At what point should my system rotate? The point at which the needle meets the plate, that's what we call the pivot point. That's the point where the center of mass can either be above or below, and that's why many objects aren't stable. Before we added the forks to the plate, we saw that the plate didn't balance. There was no way that we were able to make the plate stable on top of that needle. The plate on its own would not have been able to balance on the needle because its center of gravity would be located above the pivot point. Before we added the forks, my pivot point was up here. By hanging the forks on the edge of the plate, the center of gravity of the system got lowered. Why? We added more mass. So the more mass we added, the lower our center of gravity became, the more attracted this object, this system, became to the earth. We saw that I tried to add different pieces of potato and it just wasn't working. I thought I made all the potatoes the same size. The bigger the potato, the less stable the system was. Here we have a ruler, a string, and a hammer. How do you think this system is stabilized? How is it possible that this hammer and ruler are hanging off of the side of the table together? They're not falling. How is this happening? How does this work? What makes the heavy hammer stay up at the edge of the table? Where is the center of gravity of this system? If you're just looking at the hammer, forgetting about the ruler, center of gravity along the hammer? How does this change when the hammer and ruler are put together? This demonstration can only be carried out if the hammer has a wooden handle. If the hammer had an iron handle as well as an iron top, the center of gravity would not be located in the iron part of the hammer. Rather, it would be located probably most likely in the center of the hammer if the whole material was made of iron. Being that the iron part of the hammer is heavier than the handle, the center of gravity is located in the iron part of the handle. The ruler and string don't add much of the weight to the system on the handle side. They make the position of the center of gravity of the whole system shift a little to the right and upwards, being that there is something on top of the hammer. If the center of gravity is under the pivot point, in this case, the point of support, it is a stable system. If the center of gravity is above the pivot point, it is unstable and falls. That being the case, where is the center of gravity located in this system?